let's reverse model and get derive expression here talk in polar coordinates. So we're going to use this diagram. We're going to say we have an object R, and there is force acting on that object, and the force is at an angle phi, and the object has displacement vector r from origin, and the displacement vector makes an angle theta with the x-axis. So tentimally a triangle like this, and we're going to say x is going to be distance yoga figure up, and y distance yoga up figure up. Okay, so in this triangle we can clearly say that cos theta should equal x over r, where r and the displacement vector here, but then arrow. So if we make x subject, x should just equal r cos theta, and if you do sin theta same triangle, we should have the sin theta should equal y over r, and if we make subject y, we should have the r sin theta should equal y. Alright, now let's translate force here to ada. They are going to translate angle where is like this, gunde x-axis like that, and let's say this angle is angle alpha, and here we can say that this angle and this angle should be equal because they are vertical opposite angles. So let's show that like that. Now let's do triangle created. In this triangle we can say that cos alpha should equal the force in the x-axis over the force translate, right? So ada and force translate, and fx is just force, is just a component of force translate but in x-axis like that. Now let's make subject the force, the component force x-axis. So fx will just equal f cos alpha like that, and if we do sin alpha, we should have we're going to have component y over the force translate, and if we make subject component y, we should have the fy should equal f sin alpha. Now we know torque for an object moving in a xy plane is just equal to this term, right? And let's substitute x, fy, y, and fx in equation A. So if we do that, we're going to get here. And now let's factor out this into common. We have the r and the f magaza are common. So let's factor out those guys. So t figure alpha, and then the figure alpha. You're going to notice that this is a difference of two angles, sine function formula. So we're going to write it like this. And now let's express a DAO in terms of angle modes. So if we do angle properties, if you relate these three angles, this guy, and this guy, you're going to see that theta plus phi should just equal alpha, and if you make phi subject, you should have alpha minus theta. And now we can replace DAO and the phi like this. Now this is the expression for torque in polar coordinates.